So here, this video deals with the standard normal distribution and using the TI-84 Plus Silver Edition calculator to help us calculate both z-scores and probabilities. So we're going to continue our discussion from the previous video. Next example, find the probability of randomly selecting a z-score greater than 1.27. So once again, I recommend always drawing your normal distribution graph and using that graph and that shaded region to help you find your probability. So 1.27 is a positive number, so that's going to go on the right side of the graph. Because it's positive, that means it's above 0, which is the mean. That is always located at the center of the graph. So 1.27 is going to be somewhere over here. And then you have to decide what portion of the graph are you going to shade. Well, we're looking for z-scores greater than 1.27. So that's going to be the right side of the graph. And so in order to calculate this probability using the graphing calculator, you need both a lower bound and an upper bound. So it's important to read the graph from left to right. Always read it from left to right. And so your shaded region starts here at 1.27 and continues this way as the z-scores get larger. And remember, this graph never actually stops. It continues to go on forever. We could think of that as positive infinity. Well, since we can't type that in the calculator, we use a very large positive number. And so from left to right, your shaded region starts at a z-score of 1.27, so that would be the lower bound. And the upper bound, well, you're shading the right region of the graph, so it continues towards positive infinity. So we use the number 999,999. Typically 6 nines are used. And so go in the calculator, clear it out, go to second, vars or variables, and go down to the second option, normal CDF. And here, I'm just going to go ahead and delete the negative. I'm sorry, I'm going to delete the whole thing. We need to put in the lower bound, which is 1.27. Press enter, clear out the upper bound. We need to put in that large number, so 999,999. And then the mean and the standard deviation, 0 and 1. That stays the same. Go down and press enter and enter again, and you end up with an area of 0.1020. So the area to the right of 1.27 is 0.1020. About 10% of the graph is here. So find the percentage of z-scores that are within one standard deviation of the mean. Well, remember the z-scores or distances along the horizontal axis. And so within one standard deviation, the z-scores also tell us how many standard deviations you are from the mean. So within one standard deviation, what they're actually talking about here, your mean is 0. And if you go out one standard deviation in both directions, your z-score is going to be -1 here and +1 here. And so you have to decide, are you shading in between these two numbers or are you shading the outer regions here? Well, within one standard deviation. So that's all the z-scores between -1 and +1. So you would shade within those two numbers. And so we should know from the very beginning that if you're within one standard deviation of the mean, that's about 68% of the graph. But we're going to actually calculate it and get a more precise number. And so here, once again, you use normal CDF because we're calculating a percentage. And so you need a lower bound and upper bound. Well, from left to right, your lower bound or your shaded region starts at -1 and ends at 1. So your lower bound is -1, your upper bound is 1. So you press second, variables to open up that distribution menu, go down to normal CDF. So clear that out. Your lower bound here would be 1. Your upper bound would be 1. And your mean and standard deviation stay the same. Press enter. And so you should expect about 68%, but to be more precise, it's about 0.6827. And of course, the question asks for a percent, so 68.27% of the graph is within 1 standard deviation of the mean. So we looked at 3 different cases of when we were finding an area, percent, or a region under the curve. So one important thing, I don't think I actually mentioned it in the previous video, is that the area under the curve, the entire area, the total area under this curve is 1, right? And that's important to note whenever we're going and finding the z-scores, okay? So moving on to another example. Find P85, or what we call the 85th percentile. What we're actually trying to find here, when we're looking for the 85th percentile, is we are looking for a z-score where you have 85% of the graph below this number. And so if 85% of the graph is below this number, and we know the total area of the graph is 1 or 100%, well, what's left over? 15%. So we're looking for a z-score separating the lower 85% of the graph from the upper 15%. So if you have 85% of the graph below this number, this unknown z-score, which is what we're actually trying to calculate, what that means is the z-score is going to have to go on the right side of the graph. It's going to have to go somewhere over here. So the 85th percentile is going to go somewhere over here because you have 85% of the graph below this number. And then that leaves 15% or 0.15 over here because this area and this area must add to 1. So here we're not actually calculating a percent, a probability, or an area like we were doing in the previous examples. This 85, that is the percent. We are given a percentage. We're trying to calculate a z-score. So we're trying to calculate a distance here, a horizontal distance on this axis. And so we have to use inverse norm. So go in your calculator, clear it out, press second, and you press the variables button. And the very third option you see is inverse norm. And you're going to put in an area here. What you have to decide is, are you going to put in the 0.85 or are you going to put in the 0.15? Well, if you go to the top, it's always area to the left of the z-score. It's the cumulative area to the left. It always has to be the area to the left. So here's my z-score. The area to the left of it is this region here, so 0.85. And you should expect your z-score here to be positive because you have such a large majority of the graph below this number and it's on the right side, so this z-score is going to be positive. That's kind of one way to know that you maybe put in the wrong number if you get a negative answer. So 0 and 1, your mean and standard deviation. Press enter, enter again, and you end up with a z-score of 1.04, rounding to 2 decimal places. So if you go out 1.04 standard deviations above the mean, you have about 85% of the graph below that number and about 15% above that number. So next question, find the 12th percentile. Find P sub 12, the 12th percentile. Well, once again, this 12 represents a percent. We're looking for a z-score, or a random variable, where you have 12% below that z-score. So you have a very small region of the graph to the left of that z-score, only 12% or 0.12. So your percentile is going to have to go somewhere on the left side of the graph, because what is to the left of that? Only 0.12 or 12% of the graph, right? So if you have 12% over here, or 0.12, the leftover 88% is going to be over here, right? Because this area to the left and the area to the right have to add to the number 1. And so here is the mean, 0, and your percentile is over on the left side of the graph. So that tells you that your z-score, your percentile, is going to be a negative number. So use inverse norm to calculate So what you first have to put in is the area to the left. So here's my percentile, or my z-score, right? The area to the left is this number here, so 0.12, 0 and 1, and so you get negative 1.17. So next question. Find the critical value z sub alpha, where alpha is 0.05. So just to remind you from the lecture notes, a definition. The critical value z sub alpha is a value where alpha is the area to the right of the critical value. So we're looking for a z-score where the area to the right of that z-score is 0.05. So your graph would look something like this, right? So your z-score is going to go on the far right end of the graph because you only have 0.05, an area of 0.05 to the right of that z-score. So a very small region of the graph is going to go on the right side, which means a very large region is going to go on the left side. And so what's important here to remember, and that's why the graphs are helpful, is if you have 0.05 on the right side of this z-score, then you need to always enter in your calculator the area to the left of the z-score. Well, this is the area to the right, right? We know the area to the right is 0.05. So the area to the left has to be 1 minus whatever the area to the right is. So 1 minus 0.05 is going to give me 0.95. So if you have 5% of the graph to the right, that means 95% or 0.95 is going to be on the left side. That's the number you have to use as the area, the cumulative area to the left of the z-score. So going in your calculator, open up that distribution menu, second variables, go down to inverse norm, and the area to the left, remember, is 0.95. Remember, here we're expecting a positive z-score because we're on the right side of the graph. And so you end up with 1.645, rounding to 3 decimal places. And so notice here your z-score is on the right side. So if you get a negative z-score, that tells you typed in the wrong area. So find the indicated z-score. So here we're just given a graph, right? Here's my z-score, which it's on the left side of the graph. So we should get a negative z-score here as an answer. And they gave us the area to the right of that z-score is 0.9265. Well, when we are using our graphing calculator, we always need the area to the left. The area to the right is 0.9265. So to figure out this area here to the left of the z-score, it's 1 minus this area to the right. So 1 minus 0.9265. So the area to the left is 0.0735. That's what we have to use to calculate this z-score. So go to second, variables. The third option is inverse norm. And you put in 0.0735, and then the mean and standard deviation stay the same. And you end up with that negative z-score.